Hey guys, welcome back to Maths Recovery with Rebecca. So today I decided that I wanted to continue with the Euclidean geometry theorems. So I don't know how your teachers have done it, so I prefer to teach it in the different sets. So there's 4 sets. So the first one is theorems involving the center. So these ones you specifically know that you have to be given the center, otherwise you cannot use them. Okay, so the first one is a line drawn from the circle center that cuts the chord perpendicularly, bisects the chord. So what we're going to do is we're going to watch this short video that I created here. And what you will see is throughout the whole video, as long as the chord CD is bisected, so as long as CE is equal to ED, that angle from the center to the chord is consistently 90. Okay, so you can see that throughout the entire short sketch there. The reason we're working with is line from center perpendicular to chord. Now, the biggest thing that I've picked up throughout my years of teaching is that people don't know how to write the reason. Like, what is the reason? And the only suggestion that I can give to you is you always ask yourself, what do I have? This is the reason. What do I have? Okay. So this one specifically, what do I have? You will see in the sketch that you have a line from the center that is perpendicular to the chord. Now that is your reason. Line from center perpendicular to chord. The conclusion after all of this is because you have a line from the center that is perpendicular to the chord is now bisected. So you have CE equaling to ED. Great. So what you can do is you can pause it and you can do these yourself, or you can watch me do them or skip to the end. It's up to you. So remember, we ask ourselves, what do we have? O is the center of the circle, which means we can use this theorem. O is the center of the circle, yes. So what I was trying to say is you need to be given the center. You cannot just assume something is the center. They can label anything O. Hopefully they don't, but they can label anything O. Okay, so just be aware that it says there in the writing that O is the center. Okay, so it says that CB, that's this whole length over here, CB is 8, OD is 3, and then they've told you that OD is perpendicular to CB. Line from center, perpendicular to chord. That's what I have. That is my reason. So what do they want? They want OB. They want this hypotenuse. How do I know it's a hypotenuse? Because it's opposite the right angle, directly opposite the right angle. It's our longest side of the triangle. So let's first start by stating that CD is equal to DB. What do I have? Line from center, perpendicular to chord. Therefore, this is going to be 4. So we know that DB is equal to 4 units. Great. So now we can just go and work out OB. If you know anything about your Pythagorean triples, you know that this is a 3, 4, 5 triangle. You're more than welcome to do Pythagoras. It's up to you, but I'm not going to. Let me just conclude this because I didn't write my units. Great. Let's look at the next one. So O is the center. They've told us that DO is square root of 3, OB is 2, and they also told us that OD is perpendicular to CB. So we have a line from the center that is perpendicular to the chord. So what does that do? It bisects the chord. Okay, the line they want us to calculate DC, which is just this length over here. So I first got to do Pythagoras. I've got to calculate DB. So dB squared is going to be the hypotenuse squared minus root 3. So I'm just doing the Pythagoras where you have the hypotenuse. So this is going to be dB squared. That's going to be 4 minus 3. That's 1. And then the square root of dB. and 1, that is 1. 1 what? 1 unit. Okay, so that is 1. This is 1. How do I know that it's 1? Because dB is equal to DC, line from center, perpendicular to chord. Great. So therefore, DC is going to be 1 unit. All good. Okay, let's look at a little bit of an advanced question. So A is the center. Again, I told you they don't have to give us O as center. They can do any letter as center. So C, B, and E, F are both chords. AG is perpendicular to EF. So line from center perpendicular to the chord bisects the chord. I know that now. DA is 5. AG, that's 7. EF, that's this whole line here. EF is 48. They want us to calculate CB, so that's this whole line over here. Great. So my thoughts are, let's first go and do Pythagoras in here, get AE. I can see that AE is a radar. So that means this radar, AB is also a radar. So whatever I get for EA, that would be the same length for AB. And then do Pythagoras here again to get DB. And then use my reason line from center perpendicular to chord. Great. So I have my way forward. Let's start. So EG is equal to GF, which is equal to 24. Line from center, perpendicular to chord. Okay, so now I know that this is 24 and this is 24. Now I'm going to do Pythagoras to find AE. AE squared, that's going to be 24 squared plus 7 squared. Remember, it's Pythagoras. So I'm going to do all of that working out, and I'm going to square root it, and I'm going to get, I think it's 625, so it's 25 centimeters. So this is 25 and this is 25. So how do I know that? Well, EA is going to be equal to AB equal radar. Great. So now I know that those are equal. These are equal. Now so just label it because you have more going on here than you kind of need to see what you've done. So now let's work out dB. That's going to be 25 squared minus 5 squared. Again, that's Pythagoras. Okay, so let's work that out. 25 squared minus 5 squared is going to be 10 root 6. What a beautiful answer. Centimeters. So this is 10 root 6. And now what do I know? I know that CD is equal to DB. What do I have? I have the line from center perpendicular to the chord. Therefore, the whole of CB is going to be 20 root 6 units. Hopefully you got that. Okay, so the last thing that I want to do is I want to do the proof. There is about 6, I think, 6 proofs throughout your whole Euclidean geometry. This one is very nice and easy. So with a proof, you have to state a few things. And how you approach a proof is you can use anything. So you can use another theorem, not this one. You can use length formula, you can use congruency, similarity, interior angles of a triangle, with construction to be able to prove a theorem that they've asked you to prove. Now, luckily for you, we give you a set way to prove these things. So you only have to learn to understand how to prove them, and then you can move on. You don't have to physically go and find your own way to prove it. So what you start off with is you start off with what were you given? So you were given that O is center. Everything that's given is in the line above. O is center. You were also given that OT is perpendicular to RS, and T lies on chord RS. Great. That's what you were given. RTP, so RTP stands for required to prove. So you're required to prove, here it is given you, that RT is equal to TS. That's what you're required to prove. Now your construction, which is your most important part of these questions, because if you don't write it, or if you don't show it on your drawing, whatever you write, you get 0. Okay, so just be specific. So I'm going to do both. So I'm going to construct OR and OS such that OR is equal to OS because they are equal radar. Great. And then now we're going to do the actual proof. Now with this specific one, you've got to use congruency. Now remember with congruency, you've got to state your triangles. So ROT and triangle SOT, and then you've got to have 3 reasons. And then your end conclusion with whatever SAS, SSA, or RHS, or anything SAS to be able to, this is your congruency. And then you got to have your end as to why we even used it. Okay, so the first thing that I'm going to state is my construction, because that was the first visual thing that I saw. So RO is equal to OS, that's going to be equal radar. And then I've got OT, that's a common line. And then I've also got T1 is equaling to T2, that's equal to 90. This was given. Okay, so therefore, my conclusion is triangle ROT is congruent to triangle SOT, and I'm going to use RHS. Because remember, if I'm going to use side angle side needs to be corner heavy. So it has to be the side and the angle that joins the two sides, the angle that's next to or adjacent to the side. But with RHS, all we need is a right angle, a hypotenuse, and a side. And that's what we've got. We've got the right angle. We have the hypotenuses, which was the radar. And then we've got this random side, which is the common line. Okay. So what does that mean for us? Well, that means that these two triangles are congruent. They're exactly the same. So that means that RT is going to equal to TS. There we go. So I've proven what they want me to prove, and I am done. There's now 6 marks. Yeah. Okay, thank you so much. Please make sure that if you have any questions for me, that you email me so I can put it on my subscriber part of my channel. I'm really keen to work on some of the difficult questions that are sent my way. Yeah, so please like and share for all your friends, and I will see you around.